how to determine the largest how to determine the largest possible domain, the largest possible domain of a function. How to determine the largest possible domain of a function. I say, for instance, we have a function f of x, okay? We have a function f of x. We want to determine the largest possible domain of this function. Now, the largest possible domain of the function consists of real numbers that are values of x, consists of all real numbers, okay, all real numbers that are x or values of x that makes the function defined. You can say that all the values of x, all the values of x which makes the function y equals f of x defined, they are called the largest possible domain. Okay. Now there are several ways to represent this domain. Okay, there are several ways to represent a domain. We can have what we call the closed interval. Okay, this is what we call the closed interval. How to represent the domain? I want to show you how to represent the domain now. The first one is what we call the closed interval. Okay, closed interval. Something like this. We have a bracket. Let's say bracket -4. Okay, to bracket close. Okay, what does this mean? This means that x is actually greater than or equal to -4, and it also means that x is less than or equal to 4. You can try to combine this. You can say this thing as saying -4 is less than or equal to x, and x is less than or equal to what? 4. This kind of interval is said to be a closed interval. Okay. Now the interval could be opened interval. We could have an opened interval. Okay. We can have an opened interval. For instance, we have something like this, -4 and 4. What does this mean? This simply means that x is not -4 and x is not 4. This means that x can be -4, x can be 4. But x is not -4, x is not 4. That means that x is greater than 4 and x is greater than -4 and x is less than 4. Okay, which means I can say that -4 is less than x and x is less than 4. So this kind of interval is called the opened interval. This kind of interval is called the closed interval. Now we could have what we call half opened and half closed. All right, half opened interval. Okay, let's say something we have half open. We have, let's say, -4 and something like this. This is half opened. It's half open interval. That tells us that x here, x is greater than -4. All right, but x is greater than -4 and x is less than or equal to 4. This is half open. You can say half open, half closed. All right, this is something that's saying -4 is less than x and less than equal to 4. Okay, it could also be like this. So we have closed open interval, we have half open interval. We can also have what we call the half closed interval. All right, we have the half closed interval. So we have half closed interval. Okay, so we have half closed interval. This means x is greater than or equal to -4, and the same x is less than 4, right? So -4 is less than or equal to x, and x is less than 4. This is a half closed interval. So when you want to represent your range or you want to represent your domain, the values of the largest possible domain, you could place them in your interval notations. The open interval, the closed interval, the half open, the half closed. Now, how do we obtain the largest possible domain of a function? Now, what is the largest possible domain of a function? It talks about the inputs, okay, the all possible inputs, okay, of x that will make the function to be defined. All right. That is to say, if I have a function y is equal to f of x, okay, the largest possible domain involves all the inputs for x that will make the function to be defined. Now, it is very easy to understand this because let's assume that I split everything into cases. Okay, let's say for instance we have case one. Let's break into cases where case one involves linear functions, where case one involves linear functions. Okay. Now, when we say a function is linear, what does that mean? It means that the highest power of that function, the highest power of the variables in that function is one. So that function becomes linear. For instance, a linear function can be y is equal to 1 minus 2x. Now, this function is a linear function. Now, what is the domain of this function? The domain of this function simply tells me all the values of x that we place in this function, and the function still remains defined. Or you can say all the values of x that we place here and the function still exists. If you check very well, you will see that all real numbers can be placed here and the function is still defined. It doesn't matter any number, any real number that I placed here, the function still gives me a defined answer. If I place 2 here, the answer is defined. If I place 4, defined. Minus 2, defined. If I place minus 10, defined. If I place minus 50, is still defined. So therefore, I can say that the range, the domain, the domain involves all real numbers. If I don't want to say it this way, I could say that the domain involves from negative infinity to positive infinity. All right. Now, how about obtaining the range of the function? How about the range of this function? What do I do to obtain the range of this function? Watch me. If I wanted to obtain the range of this function, all I would just simply do is make x is always on the formula here. If I make x subject, I'll be having that 2x is equal to 1 minus y. If I find the value of x, I'll be having x is equal to 1 minus y divided by 2, which finally gives me 1 over 2 into 1 minus y. Okay? Now, if I still see from here, this is also a linear function. Okay? Because the function is still linear, so therefore the range still involves all real numbers, or you can write it in terms of intervals. Okay? In terms of intervals could be like this, all real numbers. Okay. Now the next case we're going to be treating is the quadratic functions. Okay. Case two. Case two is the quadratic functions. What is the quadratic function? The quadratic function, a quadratic function conforms to this general form ax squared plus bx plus c. This is a quadratic function. Okay. Now, I could obtain the range or the domain of a quadratic function. The domain of a quadratic function, once you see that the function is quadratic, that is the highest power of the unknown, the highest power of the variable here is 2. It is a quadratic function. To obtain the domain is still all real numbers. It is still all real numbers. Okay, the domain is so the domain for quadratic equation is all real numbers. However, to obtain the range of quadratic functions, to obtain the range, it depends on the kind of curve that you have. You know, quadratic equations produces a parabola, parabolic shape, produces a parabola. All right. Now, if a is greater than 0, what we have is a minimum curve, a curve that opens upwards. Okay, it's a minimum curve. So my value for the vertex is minimum value of x and the minimum value of y. Okay. Now, What is the minimum value of y? What is it equal to? It is equal to 4ac minus b squared over 4a. If you want to obtain the minimum value of y, you get that. Okay. Now, this value can give you minimum value or maximum value. So the minimum value of y or maximum value of y can be obtained from the same formula. Also, the minimum value of x and maximum value of x can be obtained from the formula minus b over 2a. Now, if a is greater than 0, I know that it's a minimum curve or minimum parabola that opens upwards. What is the range? The range is very easy to obtain. The range is going to be equal to, remember the condition, a is greater than 0. That's the first condition, okay? Curve is minimum. There's a x minimum, there's a y minimum, okay? Now, what is the range? Now, the range is going to start from, the value you got for your y minimum to positive infinity. The value you got for your y minimum to positive infinity. This will be the range, right? Now, what if what we have is the other case? What if what we have is the other case where a is now less than 0? The value for a is less than 0. When the value for a is less than 0, what we have is a maximum curve, a curve that opens downwards, okay? Now, this curve has its vertex, okay, to be here, and it has x maximum for the vertex and y maximum for the vertex. Now, since I know that this a is less than 0, x maximum, y maximum together gives us the coordinate of the vertex here. What is my x maximum? My x maximum is still minus b over 2a, and my y maximum is still 4ac minus b squared over 4a. Okay, but since a is less than 0, what do I do here? It's going to be negative infinity and y maximum. Okay, so we should find the range and domain of the function. Now, this is the function. It's a quadratic equation, obviously. The quadratic function, obviously. Now, the value for a is 3, the value for b is minus 2, and the value for c is 1. Right? Now, the first step is to see that the kind of parabola that will be formed here, remember that we can see clearly that a is greater than 0, which means the kind of parabola that we're going to form here is a minimum parabola, this that opens upwards, and this minimum parabola has a vertex, and this vertex has the minimum value of x and the minimum value of y. Now, we know what we need is the minimum value of y, and I told you how to obtain minimum value of y. We know that to obtain the minimum value of y, it is going to be equal to 4ac minus b squared over 4a. Alright, so let's place all our values. For y minimum, what we have is 4 into a is 3, c is 1, minus b squared, that's minus 2 squared, okay? Minus 2 squared divided by 4 into a is 3. So what we have here is y minimum is equal to 12 minus 4 over 12. That gives us 8 over 12. And this finally gives us 2 over 3. Okay, this gives us 2 over 3. So the minimum value of y is 2 over 3. Now, how do we write the range of this function? To obtain the range of this function, what do we do? To obtain the range of this function, I'll just say here, since a is greater than 0, I'll just say it gives me 2 over 3 till positive infinity. This is the range. Okay, 2 over 3. That is from, this bracket here, this parenthesis here, this is a bracket here. Okay, the bracket here tells me that it starts from 2 over 3. Okay, it starts from 2 over 3. Okay, till infinity. Okay, yes. Now, how about the domain? This is the range. How about the domain? Now, since I know that the function is a quadratic function, the domain, I should always remember that the domain for quadratic function involves all real numbers. All real numbers, okay? All real numbers. This is the method. Now, this is method 2. Okay, method 2, solving this question. Now, the domain is still the same, all real numbers, okay? But let's talk about the range. Now, for us to obtain the range, okay, let's see how to make x subject of the equation. If I want to make x subject of the equation, I can see that this equation here has x to appear. X is carrying a square there, which means I cannot easily make x subject. Let me show you what I mean. If I bring in everything on the right hand side to come to this side, what I'll be having, okay, let me take this side to be like this. Let me take y like this, easier like that. So I'll be having 0 is equal to 3x squared minus 2x plus 1. If y crosses, it becomes minus y. So what we have here is 3x squared minus 2x plus 1 minus y equal to 0. Now, the only way for me to make x subjects is to apply our general formula method. Okay, that is to say that to make x subject or make x standalone, I'll be having minus b plus or minus square root of b squared minus 4ac divided by 2a. If I place all the value a, b, and c, I'll have that x is equal to minus b is minus 2, plus or minus square root of b squared, that's minus 2 squared minus 4a is 3, c is 1 minus y, so this is c, this is b, this is a, okay, divided by 2 into a. So what I have here, I'm having x gives us 2 plus or minus square root of minus 2 squared gives us 4. So this we have minus 12 into 1 minus y divided by 6. Alright. So this gives me x is equal to 2 plus or minus square root of, this gives me 4 minus 12 plus 12y over 6. Okay. I want to continue from here. X therefore is equal to 2 plus or minus square root of, now this is 4 minus 12 is minus 8. So we can write it like this, 12y minus 8 over 6. Now, for this function to be defined, because of this square root that we have here, it's an even square root. And for even square root, when we have an even square root, what is inside cannot be negative. The square root of a negative number will give us something undefined. It gives us an undefined number, which is a complex number. Okay. Remember, that the value for y should be real. So anything that is involving complex numbers, we cannot include here. All right. So now, because of the fact that what we have here is an even square root, what is inside cannot be less than 0, but it can be 0, which means that 12y minus 8 can be greater than or equal to 0, which means that 12y should be greater than or equal to what? 8, and y should be greater than or equal to 8 over 12, which means that y is greater than or equal to 2 over 3. If I decide to draw this on a normal line, this is what we have. We have that if this is a number line, where do we have 2 over 3? It should be positive 2 over 3. Greater than or equal to means it starts from here, okay, down to positive infinity. Okay. So if I want to write this in interval notation, I could say that it starts from 2 over 3 to infinity. This is the range. Okay. And this is your second method. Right. So if we can see that the first method and the second method actually gives us or helps us arrive at the same answer. The next question we have down here is another case that shows the square root, how to obtain the domain and the range of the square root of a linear function. So it means that for this kind of function, there is a square root, okay, and the function is x minus 3 in here and 2x minus 1 here. All right. Now, one thing that you should note about when we have a square root, when we have a fourth root, when we have a sixth root, when we have an nth root, okay, when we have an nth root of a function, now if n is even, then what is inside the root cannot be negative. It cannot be negative. But if n is odd, what is inside could be negative. That is why you could look for the fourth root of, okay, you could look for the third root of minus 1, but you cannot find the square root of minus 1. Square root, the n is 2. Remember, for square root, n is 2, but you don't write the value for 2 here for square root, okay? Also, you could look for the fifth root of minus 1, but you cannot look for the sixth root of minus 1, okay? So what it means is that you should always note that once you have an nth root when n is even, a negative cannot be inside. Take note of that. Now, with this idea, we can start with the first question. Let's start with the first question that says, what if f of x is equal to square root of x minus 3? Okay. Now, for this function to be defined, x minus 3 can be 0 because square root of 0 is still 0. So square root of 0 is defined. Okay. But it should also be greater than 0. So it can be equal to 0 or it should be greater than 0. Okay, because we cannot have a negative. 3 is greater than or equal to 0. It means that x can be greater than or equal to 3. Okay, so what is my possible domain? What is my possible domain? Draw a number line here. Okay, this is 3. Now x should be greater than or equal to 3, which means it can start from 3, but it should move above 3. Okay, so it goes from here down to positive infinity. So how do I write the domain in terms of notation? In terms of the interval notation, this is 3 infinity. Or you could say, that x is all real numbers except x being less than 3. Okay, it's all real numbers except x being less than 3. So this statement and this statement, they mean the same thing. All right, let's go to the next question. Or okay, let's use the same opportunity to look for the range. How do we find a range? Remember that f of x is equal to square root of x minus 3. Okay, so if I say let f of x be equal to y, I can say that y is equal to square root of x minus 3. Okay, now if I wanted to remove the square root from here, because I want to make x subject, I will have to square both sides. Okay, if I square both sides, I'm having y squared is equal to x minus 3. Okay, so if I make x subject, what becomes x? X becomes y squared plus 3. Alright. Now if x is y squared plus 3, now with what we have, this is a quadratic function. Alright. I remember when we have a quadratic function here, there is no value for y that will be placed here that will make this function undefined. You check it very well. Even if you're going from 0 to positive infinity, any number that you substitute, any number of y that you placed here from 0, okay, from 0 to positive infinity, any number that you place here for y, will not make this function undefined. Why? Because of this square root here. This square, not square root, this square here. The square of a negative number is positive. Okay. Now, even if I take it down from 0 to negative infinity, if I place any value of y here, it doesn't still give me an undefined value. Okay, it's still defined. So therefore, I can say that the range, the range, the range involves all real numbers. Okay, which means from negative infinity to positive infinity. What if f of x is equal to square root of 2x minus 1? Okay, now we have to look for the domain first. How do we get the domain? Okay, remember this is still the square root of a linear function. Remember, once we have the square root, what is inside the square root should be greater than or equal to 1. It cannot be less than 1, but it can be 0. So 2x is greater than or equal to 1, and x is greater than or equal to 1 over 2. So the domain, so therefore the domain is actually from 1 over 2 to infinity. This is the domain from 1 over 2 to infinity. Now, how about the range? How about the range? You can still do the same thing to obtain the range here. Okay? I'll do the same thing to obtain the range. What we did before. Let's let's let f of x be equal to y. So I can say from here that y is equal to square root of 2x minus 1. I can say this. So now in trying to make x sort of formula, I have to square both sides. So when I square both sides, okay, this is y squared is equal to 2x minus 1. Okay, let's make x subject. So we have y squared plus 1 is equal to 2x. So my x is equal to y squared plus 1 over 2. Okay, y squared plus 1 over 2. Now, from what we have there, this is also a quadratic function. Okay, so I can say there's no value of y between from negative infinity to positive infinity. There is no value of y that I'm going to place here that will make this function undefined. Because of this singular reason, my range, my range is still all real numbers. Or I can say that my range involves from negative infinity to positive infinity. It's a quadratic function with a square root. Okay, this is the next case 4. That is a quadratic function that has a square root. Alright, now this is how we go about this. Now, because it is a square root, what is inside cannot be a negative number, which means now what is inside cannot be a negative number, but it can be 0, which means that what is inside, which is x squared plus 3x, x for 3x minus 28, should be greater than or equal to 0. Now, this is a quadratic equation. I can factorize it. When I factorize it, my factors should be 7 and minus 4. Okay, so my factors. How do I get the factors of the quadratic equation? Remember, you look for two numbers such that when I add them, I'll get 3. And when I multiply them, I'll get minus 8. Okay, minus 28. Okay, because remember, this minus 28 is gotten from multiplying this guy and this guy. Okay, so when I multiply 1 times minus 28, I'll get minus 28. So I'll look for two factors from here such that when I add them, I'll get plus 3. When I multiply them, I'll get minus 28. Okay, now these two factors obviously are 7 and minus 4. So that's how I knew that these are the correct factors to use for my factorization. That is how I knew. All right. Now, Since I know my factors are 7x and minus 4x, so I can say from here this is x squared plus 7x minus 4x minus 28 greater than or equal to 0. Okay, so what we have here becomes x into x plus 7 minus, if I bring out minus 4, I'll be having x plus 7 still greater than or equal to 0. So I can say x minus 4 into x plus 7. Okay, now this is greater than or equal to 0. Now I could start this way. I could say from here that x can be equal to 4, x can be equal to 4, or x can be equal to minus 7. Okay, so I start from, since all of this equal to sign here, okay, this can be equal to 0 and this can be equal to 0. All right, now I'm going to, for my number line, I want to predict my possible domain for my number line. So since x can be 4 and x can be 7, I'll say, okay, x can be 4 and x can be 7. Now let's check for between negative infinity and 4. Okay, minus 7. Okay, minus 7 will be placed here. Okay, 4 will be placed here. So let's check now between minus infinity and minus 7. Let's see if there are values, if the domain can exist here, if the function will exist, if any of the domain is here. Let's see. So let's pick any number between here and here. Pick any number, say minus 8, for instance. So if I watch me, if I place minus 8 here, I'll be having minus 8 minus 4 into minus 8 plus 7. Okay, let's see. This gives us minus 12 times minus 1. Minus 12 times minus 1 will definitely give us a positive number, which is positive 12. And positive 12 is greater than 0. So it is very possible that the domain exists here. A function will exist here if the value of x is placed between minus infinity and minus 7. It will exist. The function is going to exist. Now let's try between minus 7 and 4. So let's try any number. Let's say 0, for instance. 0 is between here and here. Let's try 0. If I place x as 0, let's see what happens. Let's place x as 0. To place x as 0, this will be 0. 0 minus 4 into 0 plus 7. Okay, so I'm going to be left with minus 4 times 7, right? Which gives me minus 28. But it should be greater than or equal to 0. But it's already showing me less than 0, minus 28. So it means that this, from here to here, I cannot choose any value of x from here to here. Okay, now let's try the last one. Between 4 and positive infinity, pick any number. You can say 5. If I pick 5, place x as 5. 5 minus 4, then into 5 plus 7. Let's see what happens. This gives us 1 times 12, and that gives us what? 12, which is greater than 0. Okay, so it means that here is accepted. So now, in terms of interval notations, how do I write this? I'm going to say from negative infinity to 7. Remember, I'm going to use a bracket for 7. Why am I using a bracket for 7? Because it will exist if I place x as 7. The function will exist. Union. Now, from here to here, not accepted, but from here to here, accepted. I can say union. It can be 4 to positive infinity. This, therefore, is your domain. To obtain the range of this function, I will just say let f of x be equal to y, so that y is equal to square root of x squared plus 3x minus 28 So I have to square both sides. So if I square both sides, I'm having here squared and here squared. Why am I squaring both sides? Because I want to make x subject of the equation. Now I now have y squared is equal to x squared plus 3x minus 28. Okay. If I collect like terms, what I'm going to be having x squared plus 3x minus 28 minus y squared. Okay. Now this is equal to 0. Now I can now say from here, this is still quadratic. I want to look for the value of x. So I can get x by saying x is equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. Okay, so what is my a here? My a here is 1, my b here is 3, my c here is minus 28 minus y squared. Okay, so this gives me x is equal to minus b plus or minus square root of b squared is 3 squared minus 4a, then c should be everything that is here, that is minus 28 minus y squared all divided by 2a. A is 1. All right, so by so again from here we can see that x is equal to minus b plus or minus, this is square root of 3 squared is 9, 3 squared is 9. Then if this minus sign comes out, it becomes plus 4 into 28 plus y squared, close it, divided by 2. This is as in x is minus 3 plus or minus square root of 9 plus 1, 2, 1. Okay, 1, 1, 2, 1, 1, 2 plus 4y squared. Okay, divided by 2. So this gives me x squared minus 3. Okay, x squared is equal to minus 3 plus or minus square root of this gives me 121, 121 plus 4y squared over 2. Now I can clearly see from what I have here that for this function, okay, for this function to be defined, what is here should be greater than or equal to 0, right? So it means that 121 plus 4y squared should be greater than or equal to 0. Now I can see clearly that from this function, there is nothing that I will place as x that's between, that is from negative infinity to positive infinity. There's no value of x that I will place here. There's no value of y rather. No, so we're looking for range. So there's no value of y that I'm going to place here that will make the function to be undefined. Okay, there's no value of y that I'm going to place here that will give this function less than 0. There's no value of y. Okay, so therefore I can say that the range involves, okay, all real numbers, or I can say the range negative infinity to positive infinity. All right.